So a short video, hopefully short, on how to do stoichiometry problems. And let's just jump right in. Here's a problem that would be solved by stoichiometry. So how many grams of oxygen are required to make 42.1 grams of water, H2O? And the steps of stoichiometry have been on the board for a while, but here they are again. First, we need a balanced equation. And let's go ahead and do that. We're turning oxygen somehow into water. So the equation is going to include both hydrogen and oxygen making water. So I'll just make my old atom inventory here. That's what I call this. 2, 2, 1. Since my oxygens are out of balance, I'll need to put a 2 here. And that changes both the H and the O. It doubles both the H and the O. So the H went from 2 to 4. O went from 1 to 2. And now on the left side, the oxygen is fine, but the hydrogen is now out of balance. So in order to make that a 4, I'll need to put a 2 there. So now our equation is balanced. We have a balanced equation. I'll check that off. Next, we got to convert something to moles. Well, the only thing we were given in the problem is grams of water, 42.1 grams of water. So we will turn that into moles by dividing that by the molar mass. And the molar mass of water just happens to be 18.02 grams per mole. And that needs to be on the bottom because I need that and that to match, so they will cancel. And now we have successfully converted our grams of water into moles of water. See, the grams of water have canceled. We've left moles of water, which is where we want it to be. I'm not going to put that in the calculator yet. So I've converted to moles. Now we need the mole ratio, where X is the coefficient of what we're trying to find in the equation, and Y is the coefficient of what we were given in the problem. So we need to look at the equation. Here's our equation. And there are a number of mole ratios that we could write from this. Right? We could compare hydrogen to water. In that case, there's 2 moles of hydrogen for every 2 moles of water. And so 2 moles of hydrogen equals 2 moles of water. And if you make a fraction out of that, whichever way you make the fraction, if the two things are equal, they both equal 1. So we're multiplying by 1. Doesn't change anything, right, mathematically. But we can use that to convert from one unit to another. All right, so if we compared oxygen and hydrogen, right, there would be a 1 here on the oxygen. So 2 moles of hydrogen require 1 mole of oxygen. So those two things are equal. So this equals 1 and this equals 1. So it's just a matter of which one of those 1s we want to multiply by. For our problem, we're comparing oxygen and water. So it's 1 mole of oxygen to make 2 moles of water. So those things are essentially equal to one another as far as the reaction is concerned. So this is 1 and this is 1. So the one that we're trying to find, the one that the problem is asking for, how many grams of O2, that's what we're trying to find. So we need O2 on top. So we're going to choose this one. So we've got our 42 grams of water times 1 mole of water over 18.02 grams of water. That was what we did in step 2. Then it will be 1 mole of O2 over 2 moles of water. So now, see, this has to be the matching with that, so they will cancel. So now we've converted from grams of water to moles of water, grams of water to moles of water, and now we've changed that to moles of O2. So we are clearly clicking right along here. We just did step 3. And now we got to convert back to grams or liters of gas or some other unit. This problem asks for grams of oxygen. So our next step then will be, we'll need to multiply by the molar mass of oxygen. So here we are, convert to grams. Right, we've already converted to moles. We've converted our moles of water to moles of oxygen. And now we just need the molar mass of oxygen. which just happens to be 32 grams of oxygen, is 1 mole of oxygen. And then we're ready to solve the problem using our calculator. 42.1 divided by 18.02 divided by 2 times 32. I get 37.38 grams of O2. Does that make sense? Well, the 32 here, let me highlight a little bit. This 32 divided by 2 would be 16. And 16 over 18, right? 16 over 18, that's a little less than 1. And so less than 1 times 42 will be less than 42. And 37 is clearly less than 42. That's a pretty good guess. Pretty good guess. All right, so we got another problem here, I think. Let me clear this all off. All right, and our next problem is up here to the left. It says, I've already got a balanced equation on this one. How many grams of Na2O are produced when 57.5 grams of sodium react? So we're looking for how many grams of Na2O. So there's my find. I always like to identify those right away. And 57.5 grams of Na, that's my given. Okay. So let me check, see if I've started this anywhere. I have not, so we'll start it right here. Right here. Oops, what is that? So we'll start with our, to fatten this up a little bit. .5 grams of Na. I need to divide that by the molar mass of Na. Na, it says, is 22.99 grams per mole, so 1 mole Na over 22.99 grams of Na. And then my mole ratio, what I'm trying to find, 2 moles Na2O over 1 mole. Nope, over 4 moles of Na, sorry. Right, it's 2 to 4. And then I needed the molar mass of Na2O. My moles of Na just canceled. My 2 and my 4 will reduce. And so the molar mass of Na2O, there's 2 Nas, which one of them is 22.99, so 45.98 for the Na. 1 atom of oxygen times 16 grams per mole for oxygen, 16.00, 45.98 plus 16, 61.98. I'll plug that in right here. And we'll do the math. 57.5 divided by 22.99 divided by 2 times 61.98. Remember, if it's on top, you hit multiply button on your calculator. If it's on the bottom, you hit divide. Even though it looks like this would be 22.99, oops, 22.99 times 2. It's still, we're dividing by 22.99, and we're dividing by 2 because they're in the denominator. That's the way the math works. Sorry if you don't like that. So my total then is, let's see, put this back into where we were starting from. I get 77.5 grams Na2O. That's all there is to it. Every problem we do the same way. This, let me do this better. Always 1, always 1. Has to cancel with this. Has to cancel with this. Has to cancel with this. Ooh, that's really ugly. That's not a highlighter. Anyway, you get the idea. So, where the highlighters are on this. Anyway, that's about the size of that. So we're always doing the same thing. You can finish up that assignment that we started on, what day was that? Tuesday? Did we start this on Tuesday? Maybe we did. Anyway, so that's what you can finish that for your e-learning assignment for today. And one more thing. Okay? Oh. I can't make it any smaller. Okay, well, you get the idea. Okay?